Hey there. Today, we're going to crack the code on a tool that lets you find pretty much any unknown value you can think of. It's called algebra. And I know, that word can sound a little scary, but forget all that. Just think of it as a secret language for solving puzzles. Let's kick things off with a really simple one.
So here's a little brain teaser for you. A concert ticket is $25 plus some kind of service fee. Your total comes out to $28. So what was the fee? You probably just solved that in your head, right? Of course, it's $3. Well, guess what? You just did algebra. Seriously.
Yep, that little calculation you just did without even thinking about it. It has a name, algebra. It's a system, a kind of secret code for finding the missing piece of any puzzle, and it works whether the puzzle is super easy or incredibly complicated.
So, how do we actually use this code? Well, first things first, we need to learn its most basic and fundamental word, the equation.
An equation is really just a statement that two things are equal. That's it. The best way to picture it is like a perfectly balanced scale. You know, where the stuff on the left side weighs exactly the same as the stuff on the right side. They're in perfect balance.
Now today, we're focusing on a special kind of equation called a linear equation. That sounds technical, I know, but it just means two really simple things. One, we're only looking for one single unknown thing at a time, which we usually just call x. And two, there's no complicated stuff like x squared or x cubed, just plain old x. It's simple, it's direct, and it is unbelievably useful.
Okay, so if an equation is a balanced scale, how do we actually use it to find anything out? How do we move things around without tipping the whole thing over? Well, it all comes down to 4 golden rules for keeping things equal.
The main idea here is just be fair. Whatever you do to one side of the scale, you have to do the exact same thing to the other side. If you add 10 to the left, you've got to add 10 to the right. If you divide the right side by 2, you have to divide the left side by 2. That's it. That's how you keep everything in perfect balance.
All right, enough theory. We've got the language, we've got the rules. It's time to put these tools to work and actually solve some real puzzles.
Let's dive into our first example from the source material. Now don't get overwhelmed by all the text. Just look at that first line there. 21 minus 3 times a minus 7 equals a plus 20. It might look a little messy, but our mission is actually really simple. Our one and only goal, no matter how complicated the equation looks, is to get the unknown thing, in this case it's a, all by itself on one side of that scale. We're going to use our 4 rules of balance to carefully clear everything else away from it.
So, by using our rules, subtracting things from both sides, adding things to both sides, we systematically chip away and isolate our unknown. And look, at the very bottom of the calculation, we find our answer, a equals 5.5. See? The code works. You follow the rules of balance, and you will find the answer.
Okay, that was pretty manageable. But what happens when the puzzles get a little uglier? What about something that trips a lot of people up? Fractions.
Now this next example looks way more intimidating, doesn't it? But here's the secret. The rules of balance don't care if a number is a fraction or a whole number. The logic is exactly the same. And there's a pro-level trick we can use to make our lives a whole lot easier.
This is the move right here. For any equation that's full of fractions, don't even try to solve it with them in there. The very first thing you should do is get rid of them. How? You find a number that all the bottom numbers, the denominators, can divide into evenly. In this case, if you look at the bottom numbers, we have a 4, a 3, and a 2. They all go into 12. So we use our multiplication rule and multiply times every single piece of the equation by 12. And just like magic, that one move makes all the fractions vanish.
And just like that, the scary fraction problem has turned back into a simple puzzle, just like the very first one we solved. From here, it's the same process. Use the rules of balance to isolate the variable, and you'll find your answer.
So now we get to the real superpower of algebra. It's not just for solving equations that somebody gives you. Its real power is turning real-world stories and problems into equations that you can then go and solve yourself. This is how you do everything from calculating a budget to planning a road trip. And there's a simple 4-step strategy for doing this. 1. Read the problem carefully to actually understand what's happening. 2. Figure out the one thing you don't know and just call it x. 3. Turn the story into a balanced equation. And 4. Solve for x. Let's try this strategy on a classic puzzle. A man is 24 years older than his son. In 2 years, he will be exactly twice as old as his son. The big question is, how old are they both right now?
Okay, step 2 of our strategy. What's the core unknown here?
It's the sun's age, right? We have no idea what it is, so let's just call it x. And if the sun's age is x, well then the man's age has to be x plus 24.
Now for step 3, the translation. This is the most important part. The key phrase in the story is in 2 years. So let's think about their future ages. In 2 years, the son will be his current age plus 2, so x plus 2. The man is x plus 24 now, so in 2 years he'll be x plus 24 plus 2, which is just x plus 26. Now, the story says the man's future age will be twice the son's future age, and that gives us our equation. You can see it right there. X plus 26 equals 2 times x plus 2. The story has now become a solvable puzzle.
And from here, we just go back to our trusty rules of balance, solve for x, and we find out it equals 22. That's our unknown. The son's current age is 22. And since the man is 24 years older, his age is 46. You see that pattern? Define the unknown, translate the story, then solve. You now know how to take a situation described in words and turn it into a mathematical truth. So now it's your turn. Here's one last puzzle for you to solve using these same principles. A rectangle's perimeter is 54 centimeters. Its length is 5 centimeters less than twice its width. Can you figure out its length? Think about that 4-step strategy. What's your unknown, and how do you translate that story into an equation?
Because that's really the big takeaway here. These puzzles, they aren't just in textbooks. They are absolutely everywhere, from figuring out a business plan to navigating with a GPS. The questions are all around you. And now, you have the fundamental tools to start finding the answers.